Hello everyone. Myself Supriya Ghadke. Today I am discuss a topic on linear differential equation. The name of the topic is shortcut method for finding the particular integral. So I am discuss the shortcut method case first. So case first is pi when f of x is equal to e raised to x where a is constant. So formula for that is if f of x is e raised to ax type and here a is in constant term, then what is the pi? So standard form of pi is 1 upon 5 of d f of x. Here f of x is e raised to x, so directly I can write here e raised to x. 1 upon 5 of d e raised to x is equal to, here we have to only replace that d by a. Replace d by a, that is equal to 1 upon 5 of a e raised to ax. One condition is given is there, phi of a not equal to 0. When phi of a not equal to 0, then this value is the particular integral. So sometimes phi of a is 0, then this is the case of failure. Now we have to use the some changes. So first we have to find the phi dash of d and put the value of replace the d by a and check out phi dash of a non-zero, then our pi is equal to x times 1 upon phi dash of a into e raised to ax. Here only the term x is multiplied extra. So p of I is equal to x times 1 upon phi dash of a. Here also replace d by a e raised to x. So there is no term of d or there is no term of differentiation, no term of integration available here. So that is the final pi. So only one condition is given there, phi dash of a is non-zero. When the phi dash of a is 0, then the second condition is pi is x square into 1 upon phi double dash of a into e raised to ax, provided phi double dash of a non-zero. By using this method we have to find the particular integral. So example of this method is find general solution of d square minus 5d plus 6 into y is equal to 3 times e raised to 5x. Here we have to check the function. Function is of type e raised to ax. So here we use case first of the shortcut method. So we have to find the general solution, so that we have to calculate the CF and also we have to calculate the particular integral. So to find the CF we have to write the auxiliary equation. So here auxiliary equation is d square minus 5d plus 6 equal to 0. Now next we have to find the roots. So roots of this equation is d equal to 3 and d equal to 2, and by using these two roots we have to write the complementary function that we have called CF, that is equal to C1 e raised to 3x plus C2 e raised to 2x. Now we have to calculate the particular integral by using the shortcut method case first. So here general form of pi is, so that is denoted by yp equal to 1 upon 5 of d f of x. Now here phi of d is d square minus 5d plus 6 and f of x is 3 times e raised to 5x. Here phi of 5 is non-zero because here 5 square is 25, 25 minus 5 into 5, that is also 25 plus 6. So 25 minus 25 plus 6 is 6, not equal to 0. So phi of 5 is non-zero. So by case first we can directly write yp is equal to 1 upon phi of d f of x, that is equal to 1 upon phi of d is d square minus 5d plus 6 and f of x is 3 times e raised to 5x. So that 3 is constant term, so keep this term as it is and e raised to 5x as it is. Only replace the term d by 5. So 5 square minus 25 plus 6. So that is 3 e raised to 5x upon 6. 3 ones are 3, 3 2s are 6. So that becomes e raised to 5x upon 2. That is our yp. Then our general solution is y is equal to yc plus yp, and value of yc is c1 e raised to 3x plus c2 e raised to 2x. So c1 e raised to 3x plus c2 e raised to 2x plus yp is e raised to 5x upon 2, e raised to 5x upon 2. So this is our general solution. Now next problem is find general solution of d2y by dx2 plus 4 times dy by dx plus 3y is equal to e raised to minus 3x. This is also the type f of x equal to e raised to ax. So here also we use the shortcut method. To find the general solution, first we have to calculate CF and then we have to calculate particular integral. So to find CF, we have to write the auxiliary equation. So here auxiliary equation is d square plus 4d plus 3 equal to 0, and root of this equation is d equal to minus 3 and d equal to minus 1. Then we have to calculate the complementary function, that is yc, that is equal to c1 e raised to minus 3x plus c2 e raised to minus x. Now we have to calculate pi. So pi is equal to yp is equal to 1 upon 5 of d f of x. Here f of x is 5 of d is d square plus 4d plus 3, and f of x is e raised to minus 3x. Now here first we have to calculate phi of minus 3 because value of a is minus 3. So put here d is equal to minus 3. So we get phi of minus 3 is equal to minus 3 square plus 4 times minus 3 plus 3 equal to 0, and case first is fails because uh, for writing the pi, first we have to find the phi of minus 3 is non-zero or phi of a not equal to 0, but here phi of minus 3 is 0, so case is fails. So we have to calculate the phi dash of d. So phi dash of d is 2d plus 4. Now we have to calculate phi dash at d equal to minus 3. So phi dash at minus 3 is 2 into minus 3 plus 4, that is minus 2, and which not equal to 0. So we get our pi here. So pi is equal to x times 1 upon phi dash of a e raised to x. Here phi dash of a non-zero, so we have to multiply x because here first derivative is occur. So power of x is 1. 1 of x times 1 upon phi dash of a e raised to x, provided phi dash of a not equal to 0. So our final solution, that is equal to x into 1 upon phi dash of minus 3 e raised to minus 3, provided phi dash of minus 3 non-zero. So pi is equal to x e raised to minus 3x upon minus 2. Here is minus 2. So general solution is yc plus yp is equal to c1 e raised to minus 3x plus c2 e raised to minus x plus x times e raised to minus 3x upon 2. So some basic formula is there. Any constant k can be expressed as k times e raised to 0x. Then our final yp is k into 1 upon phi of 0. We can directly find out the value of yp if the f of x is constant term, that is k. Then our yp, that is particular integral, is k times 1 upon phi of 0. So second, if f of x is of the form a raised to x, if f of x is of the form a raised to x, then use the term a raised to x is equal to e raised to x into log a. So here we have to replace yp is equal to, replace d by log a, replace only d by log a, then our yp becomes 1 upon phi of log a raised to x. And the next formula is 1 upon d minus a e raised to ax is equal to x times e raised to x. And in general form, 1 upon d minus a raised to r e raised to ax is equal to x raised to r upon r factorial e raised to ax. By using this formula, we have to solve this problem. So find the general solution of d minus 1 cube y is equal to e raised to x plus 2 raised to x minus 3 by 2. Okay. So example is find the general solution of d minus 1 cube y is equal to e raised to x plus 2 raised to x minus 3 by 2. So to find a CF, consider AE, that is auxiliary equation, d minus 1 cube equal to 0. Roots are 1 1 1. So roots are repeated 3 times and these roots are real. So our complementary function contains three constants uh, are in the linear combination. So c1 plus c2x plus c3x square into e raised to x, that is our yc. So now we have to find the particular integral, that is equal to 1 upon d minus 1 cube e raised to x plus 2 raised to x minus 3 by 2. So we have to separate out these three terms. So 1 upon d minus 1 cube e raised to x plus 1 upon d minus 1 cube 2 raised to x plus 1 upon d minus 1 cube into minus 3 by 2. So for the first term we have the direct formula. If 1 upon d minus a raised to r e raised to ax, then the formula is x raised to r upon r factorial e raised to ax. So by using this formula we get here r is 3, so x raised to 3 upon 3 factorial e raised to x. Here a is 1 plus here we have to remove. Here 2 raised to x is term. So here we have to write replace d by log a. So here a is 2. So therefore 1 upon log 2 minus 1 cube 2 raised to x. Here we have to use the formula. If the f of x is of the form a raised to x, then replace d by log a and write down the pi. Pi is equal to 1 upon phi of log a into a raised to x. So by using this formula we get this term 1 upon log 2 minus 1 cube into 2 raised to x minus this term is k, that is constant term, minus 3 by 2 times. So if the constant is appear, then yp is equal to k into 1 upon phi of 0. So put here value of d is 0. So minus 3 by 2 is a constant term kept outside here, minus 3 by 2 1 upon phi of 0. So put the value of d is 0. So 0 minus 1 bracket cube. So minus 1 cube is minus 1, minus minus plus becomes plus here. So our pi is x cube upon 6 e raised to x plus 1 upon log 2. So 1 upon log 2 minus 1 cube 2 raised to x plus 3 by 2. That is the value of pi, and by combining these values cf and pi we get the general solution. Thank you for watching the video. I hope you like this video. If you don't subscribe my channel, so please subscribe and like the video. Thank you.